So hi everybody. Welcome to our webinar, Capabilities of Trinity F90 Plus with RedEdge-MX Dual Camera System. The attendees are already here. Can you hear me? Can maybe somebody write something in the questions if the audio is okay and you can see us? Yeah, the first yes is coming. So that's all good. Audio is good. Very good. We like that. We appreciate it. All right. Then I think we wait for a few more minutes to start. Let's say 2-3 minutes, and then we'll start with the webinar. So, hi again. It's a few minutes after 5 o'clock here in Central Europe. Welcome you everybody all over the world joining us, our webinar about the capabilities of the Trinity F90 Plus in combination with the MicaSense RedEdge-MX Dual Camera System. Just a few rules for this webinar. You are muted all the time, but you have the possibility to ask questions all the time. There's a question section in GoToWebinar. You find some handouts. There are 4 handouts, a few from MicaSense, 2 webinar handouts from us about the Trinity, the Tron, our civil line, and our governmental line, the Vector Scorpion. You find also a brochure. After this session, we have a question-answer session. Please feel free to ask questions in written form all the time. Drew and me will look for some questions and answer them right after this webinar. And all the other questions we cannot answer right now, we will answer you in a written form the next days. So, to my person, my name is Stefan Wurmser. I'm in charge for business development and training here at Quantum-Systems in Germany. My background, I studied geography. I was almost 10 years in the geoinformation branch in the German Armed Forces, and in early 2018 I entered to work on Quantum-Systems. With me today is Drew Bastian from MicaSense. Please, Drew, introduce yourself.
Thanks, Stefan. My name's Drew Bastian. I'm the business development manager at MicaSense. I've been with the company for about 4 years. I have a pretty strong background in agriculture. This is the second ag tech company that I've worked for. I worked for the Climate Corporation in sales for a few years, and then a precision ag dealer before that. And I actually grew up on a farm in Iowa in the Midwest in the US. And as you can see, both Stefan and I are embracing the quarantine hairstyle these days, as you can tell from our photos. So yeah, hope you enjoy the webinar.
Yeah, haircuts changed a little bit over the last 6 weeks. So for the agenda for today, we want to introduce you first both companies. I talk a few sentences about Quantum-Systems. Drew will talk about MicaSense. Afterwards, I will introduce to you the Trinity F90 Plus in all its abilities. Then Drew will explain the MicaSense Dual Camera. Then we will compare satellite data to the camera captured by the Dual Camera. Then we have some use cases. And in the end, I will show you a live processing 10-band imagery project we did last week or 2 weeks ago with the Trinity here in southern Germany. And in the end, as I said, we have a question-answer session. But feel free to ask the questions right now, and we pick some questions and answer them, and the rest, as I said, in written form. So let's begin. I forgot to say we have some polls. The first one, I start now. I give you a few seconds to answer. Quite interesting question for us. Which kind of drone do you currently use? Would be kind of you if you participate. If you use no drone yet, or multicopters, fixed wing, or even the Quantum-Systems Trinity or other VTOL fixed wing. So not many changes anymore. So I think most of you have answered already. In a few seconds, I'll close the poll. And share the result with you. Yeah, about what's 30% no drone yet. So we have to change that, of course. Also the multicopter, 70% is too much. We have to change that also. Fixed wing and already 16% Quantum-Systems Trinity and 10% other VTOL fixed wing. Quite interesting, especially for our webinar today, because of the copters, I think you are quite limited with the area you can cover. So today we will introduce to you the first fixed wing integration of the dual camera systems of MicaSense. So. Here we go.
Yeah, so just giving you a bit of a background on MicaSense as a company. For those of you on the call who aren't familiar with us, we were founded in 2014 in Seattle, Washington. So we have our headquarters in Seattle, and we also manufacture the camera just a couple of miles down from our office. So we're made in the U.S. And we're pretty much 100% focused on developing multispectral imaging hardware. As you can see in the image, those are kind of a historical model changes of our RedEdge camera. Now we offer a few other sensors, but I thought it was interesting to see what you see nearest to us, the RedEdge-2, then the RedEdge-3 a bit farther away, then the RedEdge-M, and then the RedEdge-MX. So we've made changes over time to improve the camera, and then of course we're going to be talking about the dual camera system on this, but we're really just focused on multispectral hardware. Our end users are typically in these four categories. So we work with a lot of researchers in the academic and commercial space. We also work with a lot of government entities like the USDA or Agri-Foods Canada or those similar such entities around the world with different governments. We're also involved with corporate agriculture, so large corporate agricultural entities, maybe who have R&D wings. Those are very common. And then we also sell to service providers who are essentially providing services to the above three categories. So that's primarily who are using our cameras. We have cameras in 80 plus countries currently, and hundreds of academic research institutions around the world are using us. So I like to say that we're arguably the standard when it comes to drone-based multispectral imagery.
Yeah, let me quickly introduce you to Quantum-Systems. The company was founded 2015 here in the Munich area in Gilching. It's 20 kilometers west of Munich in southern Germany. We are completely focused on electrical VTOL fixed wing drones, in developing, manufacturing, and also researching new solutions. Actually, we are about 50 plus employees, still growing, maybe 60 plus now. We are very proud of our self-developed flight planning software. I'll show you later a little bit about that software. We are also very proud about the self-developed autopilot software. So we are not dependent on third-party software deployers. And we recently, yesterday, we moved to a new building in beginning of May. just you see it's outside of the building is still a construction site, but we're already working in there. You see on the screen our payload compartment, the dual RedEdge payload compartment. I get it also here in live. You see the integration of the blue camera and the red camera in this easy swappable payload. You can plug and play in the Trinity. You don't need any screws or tools for changing the payloads. And for getting the data, you don't even have to remove the payload compartment because the data is stored on these SD cards on side of the payload compartment. The Trinity F90 Plus, we offer since a few months and end of last year. It's also like the other drones, we offer an electrical VTOL fixed wing drone with extended flight time of up to 90 minutes. So you can, depending on the sensor, you can cover up to 700 hectares. It's depending on most of the site overlap. As I said, we offer various payloads, more or less all the MicaSense portfolio, from the RedEdge-MX to the Altum, to the dual payload. The whole Trinity is made as a modular design. It's easy assembling. I'll show you the next screen. We have the Cubase. You see my back, one of these roll-ups. The intuitive mission planning. The drone is PPK ready. So we offer the drone with a better than 2 centimeter accuracy as a whole complete package below $20,000, including PPK solution and iBase. iBase, maybe I have to explain, it's a entry-level GNSS receiver, a base station you can use besides your Trimble, Leica, what else station as well. The Trinity has a high wind resistance. You can fly up to 9 meters per second. Sorry for the metric numbers, but I know it from heart in another. Just know it in 9 meters per second. You can calculate it yourself. You're also able to, for easy takeoff and landing on slopes, you are not demanding a flat area, so it's not a problem to land on hilly or mountainous areas. And with all that together, you can imagine many application scenarios, from forestry, agriculture, surveying, and many more. That's how you can assemble and disassemble the Trinity. If you're a little bit skilled, you make it in less than a minute, 1 minute, 2 minutes, out of the box of this robust transport case. You can carry it with you in luggage and on the plane. It's not a problem. We offer spare parts. For example, if one of the wings is broken, you step on it, it's not a problem. You can easily replace it. The battery is also extra part, the main body, 2 wings, elevator, the rear fuselage. That's it. Just click, and then in 2 minutes you are more or less mission ready. Just explain in a few words the PPK solution. We offer PPK solution in, as you said, it's more reliable than RTK. You don't need the real connection all the time. You can do the processing afterwards. You fly, you land, and afterwards you bring both together. The log the Trinity is capturing as a rover and the base station. So it does not has no problems if you use your here's a MLIT GNSS station on the screen. You can use your Trimble, Leica, MLIT, what else, or our iBase I mentioned already, or Rhinex file from a course network, for example. That's everything is possible as a base station. You bring them together in post-processing afterwards in our software in Cubase 3D, and you get accuracy, yeah, between 1 to 3 centimeters, usually down to 2 centimeters. That's the screen of our Cubase 3D of our planning software. You can choose your UAV model. You can choose your camera. For example, RedEdge-MX, RedEdge Dual, Sony RX1, what else? And you can afterwards, after planning, You see in the lower right section, you see the planning in 3D. So you can imagine if it works with the terrain, have a sufficient overlay and ground sample distance, you can everything figure out in the software. And also use it afterwards for geotagging and for the PPK process. These are the payloads I mentioned earlier. As let's say the entry-level payload, we offer the 20 megapixel Sony UMC R10C, standard payload for point clouds, surface models, autophotos. You get around a ground sample distance about 2.6 centimeters from 100-meter altitude. If you go one step further, you get the Sony RX1 R2 with 42 megapixel with 1.3 centimeters and 100-meter flight altitude. And then we step over to the MicaSense portfolio with the MicaSense RedEdge-MX with 5 bands, with the blue, green, red, red edge, and near infrared, around 7 centimeters in 100-meter altitude. And MicaSense Altum, you see, with around 4 centimeters, with the thermal band extra. We offer also a combination because the Trinity is able to carry payloads up to 700 grams. So it's possible to combine, make a combined payload compartment with the Sony UMC and the MicaSense RedEdge-MX. So you get multispectral data and high resolution RGB image in one payload compartment. And just released the MicaSense RedEdge-MX Dual Camera with a 10-band multispectral camera. Drew will talk about it in a few seconds. With 2 blue bands, 2 green bands, 2 red bands, 3 red edge bands, and 1 infrared band. You have a vast possibility of indices and get also a resolution up to around 7 centimeters from 100-meter altitude. So, Drew.
All right, yeah, thanks, Stefan. I should add that to my knowledge, the Quantum-Systems Trinity is the only fixed-wing drone that has payloads for all 3 of our sensor systems. So Stefan mentioned that that was a capability, but I think that's the only thing available on the market currently that has that capability. So I'm going to go into talking about just some basics of multispectral imagery so that we're all on the same page. But before I do that, I'm going to do another poll. So give me 1 second. Are you currently using a multispectral camera of some kind? I'll let that run for maybe 15 more seconds. We've got 50% participation, 58, 60%. All right, 60% participation, that looks pretty good. So 67% are using a multispectral camera of some kind, so that's actually pretty good. And then 33% have not. So I'm guessing, based on the poll results there, I'm guessing that the next couple slides are going to be somewhat review for the 67% of you who own a multispectral camera already, but maybe it'll be useful for the other 33%. So what does a multispectral camera capture? This little diagram here, it's pretty elementary, but it gets the point across. So essentially, light energy from the sun is beating down on a plant canopy, and that light is either getting absorbed by the plant and used for growth for photosynthetic activity. It's getting transmitted or it's getting reflected. And the light that's getting reflected is what is being captured by our RedEdge, by our Altum, by our dual cam system. Really any kind of passive sensing, remote sensing is going to be picking up some sort of reflected light. And so this arrow right here is representing the visible light that's getting reflected and the near infrared that's getting reflected off the plant canopy. Trying to go to the next slide here. we go. Oop. So when we look at the typical plant reflectance profile, it typically looks like this. Let me explain the graph a bit first. So percentage reflectance is represented by the y-axis from 0 to 50% over here. And then on the x-axis, we're looking at a portion of the light spectrum, the visible light right here, blue, green, red, and then into near infrared. And then inside the graph, we're looking at a green line representing the typical reflectance of a healthy plant. And so if you follow that line from left to right, you'll see it has very low reflectance at blue. It bumps up a little bit at green, and then it drops back down again at red, and then it increases quite a bit into the red edge and near infrared. And so if you think about it, this makes sense. If you're out in the summertime, right now it's springtime, things are starting to turn green, things are starting to grow. So plants are active in photosynthetic activity. They're absorbing a lot of blue light and a lot of red light to do that. And so you don't really see plants as red until they start to die. Going into the fall or into the autumn, you start to see leaves turn from green to yellow to red. That's because they're not using that light anymore. So instead of absorbing a lot of red light, they start to kick it back, and we start to see that because it's in the visual portion of the spectrum. So that's kind of a simple explanation of how reflectance works and how it relates to physiology of the plant. So as a plant starts to change physiologically due to stress or due to excess nutrients, deficiency in nutrients, excess water, drought stress, etc., any kind of physiological change is going to be displayed in a reflectance change. And so let me just go to the next slide. It's always jumping on me. So what we're doing with multispectral imaging is we're capturing specific points along that plant's reflectance profile to better understand the physiological changes that are occurring. So right here, I've got the RedEdge-MX pictured, and I'm just displaying each of the 5 spectral bands, positions and bandwidths along that profile. So we've got blue at 475, green at 560, red at 668, red edge at 717, and near infrared at 840. So we've got these points of reference where we can see reflectance changes at the pixel level to better understand how things are happening across the field, variability, etc. And the indices that you've probably heard of, NDVI, NDRE, those terms get thrown around quite a bit in agricultural remote sensing. But just so we understand, NDVI is essentially just created using reflectance points at red and near infrared. So we're using near infrared reflectance and red reflectance. We punch it into this equation, and it gives us an index that's pretty highly correlated with biomass variability. NDRE is using reflectance data at red edge and near infrared to give us more of an understanding of the chlorophyll content and biomass variability. So you can make all kinds of indices and composites by combining, dividing, adding, subtracting these different points of reflectance that you capture with a multispectral camera. So getting into more details on MicaSense sensors, I mentioned the RedEdge camera that we've been offering since we started in 2014, but we've expanded our portfolio a bit to include the Altum, which is a higher resolution multispectral camera. It also has a thermal layer, a thermal band from FLIR in there, so you're capturing 6 bands, 5 multispectral, 1 thermal. This is our light sensor that goes on top of the drone. It's integrated into the Trinity, and this is capturing changes in lighting conditions as the drone is flying, and that's written into the metadata, so we can get better radiometric accuracy once the data is processed. And that allows us to make comparisons over time, which is really important, especially on the research side. And so what we did at the end of last year is we took the RedEdge-MX camera, and we essentially just chose 5 additional filters and made some design changes, just some aesthetic design changes, the color blue, so you could differentiate the two. And we added those 5 filters to this camera, and we called it the RedEdge-MX Blue. And then we paired these 2 cameras together, so their capture is synchronized, and suddenly we have a 10-band system. So we're capturing 10 spectral bands instead of 5. And so the reason we did this was because a lot of people were asking us to do this. We'd done some experimental pairing of 2 cameras together with custom bands in the past, but it was kind of like one-off deals. But what we did was we essentially compiled all of the requests for custom bands that we've gotten over the years, and we chose the ones that were most frequently requested, and also took into account which spectral bands are going to best complement the current bands of the RedEdge-MX. And so, as you can see here, I've just got the RedEdge-MX bands at the top. So this is 475, this is 560, this is 668, 717, and 840. So those are the bands that, if you currently own a RedEdge or an Altum, that's what you're capturing. So the RedEdge-MX Blue is capturing data at 444. So this is a coastal blue band. This was a band that was really requested quite a bit. It's good for classifying aquatic plants. It's good at indicating what's mixed into water. So people who are doing flights over water, they were wanting this to just better understand maybe the content of the water or sort of water applications, a lot of conservation work. Band 3, it's actually the second band of the RedEdge-MX Blue, but it's band 3 of the 10-band system, is this 531 band. This was another pretty frequently requested band, and we added this into the Blue. It's relevant for physiology studies. So there's an index called PRI. It's the Photochemical Reflectance Index. This is kind of a boutique index that is used to better understand the physiology of a plant. People were requesting this from us quite a bit, so we added that into the Blue. Band 5 is 650. And the benefit of band 5 is that the chlorophyll absorption at band 5 isn't as strong as it is compared to 668. So I mentioned earlier that the plant is absorbing a lot of red light when it's healthy and it's going through photosynthesis. Sometimes that can be a bit too extreme. So for example, if you're looking at corn or sugarcane mid-season when the canopy is really full, sometimes that red absorption can bottom out, and so you essentially get saturation in the red, and you can't as easily see variability across the plant canopy. Well, the benefit of the 650 is that if you run into that scenario where you're bottomed out at red, we can shift over a bit and look at the 650 red band, and we can still see how variability is occurring across the canopy. Band 7, 705. This is a RedEdge band. It's like just beyond red. It's good at identifying chlorosis, leaf roll, leaf blotch. There's studies that show that it's good in identifying micro and macronutrient deficiencies, and it's also better for planophile canopies. So I'll mention planophile and erectophile. So planophile canopies, you can think of those as plants where they're kind of parallel to the sky, so they open up and they show their leaves to the sky. Erectophile plants would be more grassy, where they're perpendicular to the sky, and so we can use different RedEdge bands to be a little bit more precise on what type of plant canopy we're looking at to get a better idea of what's going on in that canopy. So these additional RedEdge bands allow us to kind of hone in on specific plant canopies. So another benefit to this 10-band system is, and another thing that we took into consideration when we were putting this together, was the correlation between Sentinel spectral bands and Landsat 8 spectral bands. So a lot of people have asked us for spectral bands that correlate with these satellite data sets, so they can correlate drone-based and satellite data if they're looking at the 2 separate data sets together. So you can see both Sentinel and Landsat 8 have a coastal blue or an aerosol blue, and that aligns pretty well with our 444. 475, that aligns well with the the blue that's a bit shifted to the right on Sentinel-2 and Landsat 8. And then I want to focus a bit more on the red edge bands here. So Sentinel has quite a few red edge bands, and we're aligning pretty well with those as well. So anyone who's wanting to do satellite versus drone-based multispectral comparisons, the 10 band can be useful for that. And so while we're on the topic of satellite versus drone-based, I thought this was an interesting comparison. So this is a composite generated from the 10 band system versus a composite, an identical composite generated from Sentinel data. So really the only reason I'm showing this is just so you can get an idea of two things. So one is that you can create the same composites with 10 band data as you can with Sentinel-2 data or Landsat 8 data. So it's easy to compare these two side by side, but then also I just wanted to point out the obvious thing, which is the difference in spatial resolution. So of course ours is closer to 8 centimeters per pixel, whereas the Sentinel-2, I think Stefan's going to get into this later, but it's more like a meter or a couple meters. I actually don't know exactly, but it's pretty obvious to see the differences. So I wanted to look at this data set a bit more closely. So this is just an area outside of Seattle that we mapped a few months ago, and it's got a little bit of wildlife. It actually does have some crops growing along the shore of this creek or this riverbed. And on the right-hand side, we're looking at an RGB composite. This is the typical RGB composite that you can create using RedEdge or Altum. So we use 668, 560, and well, I guess we did use 444 in this case. So we use the blue from RedEdge-MX Blue. But what I wanted to point out here is we can create different composites with this 10 band data that help us delineate species from each other and just like image classification in general. So if we look at the next slide, I think it's a zoomed in image of this data set. And what you'll notice, and at least what I noticed, is that over here, I kind of see two different colors, generally speaking. I see green and I see brown. I think if you really look at it and analyze it, you can see more than just those two colors, but that's what initially jumps out at me is basically two groups of colors. We can create composites that help us better delineate the different ground cover that are occurring in this data set, and really the different species that are occurring across this data set. So it's not only easier for us to visually differentiate the species from each other and the ground cover from each other, but it's also easier for a computer or a machine to do that. And so this is just an example of us running a pretty simple image classification on this particular data set, delineating between soil, sand, water, grass, trees, etc. So you can see in the key code that it's broken down into quite a few different image classifications. And again, this was just kind of for just to get your gears turning and to help you understand the possibilities of the dual camera data. To tie this to a more relevant real world application, I'd encourage you to take a look at a blog post that we did a few months ago on a boreal peatland reclamation project, a case study. So if you go to blog.micasense.com, you'll see more about that. But essentially in Alberta, Canada, there's this peat mining or oil sand mining that's going on. And the objective of the people that were flying that area after it had been mined was to obtain detailed vegetation community composition inventories. And so it's highly regulated industry where you have to kind of bring things back to the way they were beforehand. And so it's really important to have an inventory, they said it best, of what is happening on the ground. And so with this 10 band data, we can much better do image classification. We can much much more effectively get an inventory of what's on the ground, which is really important for people in conservation and sort of reclamation type activities. So this is just I think this is a citrus grove, and I wanted to show the differences between NDRE. So we're using just the typical bands for NDRE, and then a composite called MCARI, where we were utilizing a new RedEdge band of 705 to generate this. So the purpose of showing this slide is just to illustrate that when you open up the data that you're collecting to 10 bands, the bands that I outlined before, you have many more possibilities of finding an index that is more effective at helping you analyze a data set. So with 5 versus 10, it's simple. You know, you have more possibilities of finding an index or a composite that's better suited for your particular application. In this example, MCARI is used to easier isolate a tree canopy from shadows and soil or grass in the rows. So you can see in the NDRE, you've got NDRE values that are kind of bleeding from tree to tree, and that's due to shadowing effects. So they must have captured this data maybe later in the day or earlier in the day when the sun was casting a shadow. And MCARI cleans that up quite a bit. And this is something that wasn't exactly possible to create this index with standard RedEdge data because this index requires a band that crosses over the 700 wavelength. And so with that 705 band, we do have that crossover. It allows us to create this index. And this is just one example of many. One website that I would recommend checking out is indexdatabase.de. So it's a website that basically is it's exactly what its name sounds like. It's a database of indices and composites. And it really shows you, it really illustrates best the different possibilities of different data sets when you have multiple spectral bands to work with. And this is just kind of building off of that. So with additional spectral bands, you have more possibilities for identifying spectral response of a specific disease. This image right here is of a banana plantation, and you can see the different color going on right here. We used a custom composite to bring this out. There's a disease that was going on in the banana plant canopy, which is kind of a neat example of delineating that sort of thing. And then another thing that's possible is just more combinations of NDVI and NDRE, the basic indices. So NDVI, as I mentioned before, is generated with NIR and red. Well, now we have two different reds. We have a 650 and we have a 668. So if you're not seeing what you're looking for in the 668, you can use the 650 and see if there's any variability from index to index. Or for NDRE, you've got many different possibilities. So you could use the 840 with the 740. You could use the 840 with the 717. You could use the 840 with the 705. We've even ran indices using the 740 as the near infrared band, and we've been able to pull things out of that data that wasn't visible using the 840. So there's just so many different possibilities of analysis with these new spectral bands. So go ahead and start this next poll. What application are you interested in implementing multispectral imagery? So production agriculture, research, conservation, forestry, or other, and be interested to see that breakdown. Getting close to 50% attendance or participation, almost 60% now. All right. And looks like these percentages are adding up to more than 100%, but I think probably what the case is that the bottom is 100% and the top two are 100%. But it gives you an idea of the interest of the audience here. So we've got quite a few interested in production agriculture, quite a few interested in research. That's not surprising to me. Forestry, that's an interesting one. So that's an industry that we're trying to put more emphasis on, and there should be a lot of potential in adoption of remote sensing and multispectral imagery that I think is untapped at this point. So thanks for participating in that. I think at this point, Stefan, I think I'm going to pass it over to you.
Yeah, thanks. Thanks a lot, Drew, for the very detailed explanation of the ability of the RedEdge Dual Camera. Of course, the Trinity can fly 90 minutes, so we cannot conquer with satellite data, the coverage of satellites. But I just want to explain a little bit in a real project we did why resolution matters. Here you see a Sentinel-2 seen 10-meter resolution versus the RedEdge dual camera resolution 8.5 centimeters was altitude of around 110 meters did the flight. It's more or less the same area. I think in Sentinel in that area you can see almost nothing. That's area called a small village here in southern Germany with a lot of ponds and small lakes. Few are for gravel. The gravel was mining, open pit mining. These are the very bright blue lakes, and some for fishing, some for bathing. And on the right, the small image, you see the bathing lake from Sentinel 2B, April 26th, so just 2 weeks old, 10 to 10 meter resolution. Yeah, hard to identify something. The next image is from PlanetScope, from satellite data with 3 meters resolution. You can recognize the lakes better, but still hard to recognize some details. At least there was a flight we did with the Trinity and the dual camera. 2 flights I combined. 8.5 centimeters, I said, was the first flight was on April 16th, and the second April 26th of 2020, just 2 weeks ago. We covered almost 100 hectares this flight. I explain a little bit in a few minutes about. Maybe Drew, you want to say some words about the speckled image you can see here?
Yeah, sure. Yeah, so Stefan was initially hesitant to show this data set just because it's not perfect. As you can see, there's some anomalies in the data set, and ultimately we thought it'd be important just to show you, just for an educational opportunity. So if probably any of you on here who have done any kind of drone mapping know that changes in lighting conditions can have an impact on the quality of the data. Stefan really just wanted to show the capabilities of land cover of the Trinity, but the cloud cover that day wasn't ideal for collecting data. So you start to see these kind of stripes because of cumulus clouds that were causing sharp shadows transitioning to bright sunlight. So you can get these kind of striping anomalies happening in that case. The DLS2 can correct that out to a certain extent, but when you're talking about really sharp shadows from dark to light, it's pretty difficult to fix that. Another thing to look out for is sunspots in the data. So like if it's solar noon and the sun's really beating down on a plant canopy, sometimes you can get reflectance of a sunspot, and that'll cause some striping too. But really ideal conditions for flights are either clear days or overcast days. Overcast days are really good because the lighting is diffuse, so you can get really good data sets in overcast days. But yeah, so that's just a bit of a background on what you're seeing in that data set. I'll pass it back to you, Stefan.
Yeah, thanks a lot. Yeah, this example was a 100-hectare flight. You saw, you see now a screenshot from our planning software from the Cubase 3D. I planned this around 1 hour flight time, 103 hectare. In the office, I planned it without any wind, and I went out to the field and I saw, oh, it's quite windy. It's began to get windy at around 1 1 o'clock, 2 o'clock. I was flying in the afternoon, and you see it maybe it's a little bit hard to read, but you will get the recording afterwards, and maybe you can see the figures. It was 6.7 meters wind speed at that day. You see the software estimated wind speed and changed the curves. So in the planning software was quite smooth curves, and in real life the autopilot mentioned the wind speed and attached it to the real flying conditions, so that the coverage was quite decent a day, although we had quite a high wind speed in that day. I wanted to show you that image now. That was my results, processed at an Ubisoft meter shape. I get from 1 hour flight 1,509 exposures, caused 10 times, 10 bands, 15,090 images. The overlap was side overlap 75%, front overlap 70%, worked quite decent. The wind direction was from west, wind speed around 6 meters per second. That you see, maybe the experience that you see it in the upper part in the Ubisoft screenshot. That's quite windy at that day. As I said, flight time was 1 hour, covered 1 hectare. And then you see in the lower section of the screen are the results. On the left is the bathing lake I showed with the Sentinel data. You maybe couldn't figure out anything. Here you see the beach and the water, some plants. In the mid section is strawberries on the foil. The workers just putting the foil away from the strawberries. And the right sections, you see, was in springtime here in Germany. The trees are just getting leaves. And now in the next slide, I'll show you some results, some band combinations. We do the 10-band camera. In the upper left sections, you see in the left RGB composite. You see, okay, there are some water plants. There are some plants, as Drew already explained. Everything's green or gray. And the other is near-infrared red-edge coastal blue composite. You see clearly some plants in the water, and you can identify more the different trees and the leaf status of the trees in this springtime. And the lower left side, it's the classical near-infrared red-green false color composites. And then the lower right, these strawberries on the foil. I used for that just the near-infrared, red edge, and red. So very bright image. You can see the small strawberry plants quite well. And the upper right is just the classical vegetation index. So thanks a lot for attending us in the webinar. Now we still have more or less 10 minutes to go. If you have some questions, feel free to ask. Drew and me will answer some of these questions coming now. And as I promised, the rest of them you get in the next days in written form. Will we get the recording of this webinar? Yes, of course, you get a recording of this webinar. I think in 2 or 3 days you will get a recording.
Yeah, one of the questions I see I can answer, it says for each exposure there will be 10 images. What is the size of each image? So yeah, every time the Trinity triggers the dual cam system, it's capturing 10 image files, 10 TIFF files. And I think the size of those is 2.5 megabytes each. So it is a lot of data that you're capturing.
Can we also get these presentations? I think you can. There's nothing against it.
There's one, Stefan, that's asking, what software did you use for post-processing?
That's up to you. Usually we use Ubisoft Metashape. We use Pix4D Mapper, Pix4D Fields. That's pretty up to you what you want to use.
There's a question. Oh, go ahead.
For me, sorry. Terrain following emission planner. Yes, of course, you can do terrain following.
The one I was going to answer was, can the Altum or RedEdge-M be integrated with the Blue MX? So unfortunately, the Altum cannot be paired with the MX Blue. There is the possibility of integrating RedEdge-M with the MX. I think if you're going to go with the Trinity, I'd probably encourage you to just get the MX and the MX Blue. We do have some trade-in offers. So I guess whoever asked that, Kevin, if you wanted to reach out, we could probably talk in more detail about the solution there.
There's one question: if an existing F90 Plus can be retrofitted with a light sensor in case I want to use a MicaSense. Yes, of course you can do that. Well, we can do it. Answer, yeah, that's possible, of course.
There's a question on what would be the highest capacity for the SD card, and we've tested up to 128 gigabytes, and I think you can go higher than that, but there's a knowledge-based article from MicaSense that talks about the specifications of the SD card to use, but you can go, I think theoretically you can go as high as you want, but we've gone up to 128.
What's the weight of this package? That's also interesting for all permissions in different countries. The whole package of the Trinity is below 5 kilogram, so 4.9 something kilogram. In US weight, maybe Drew, it's around 10 pounds.
Here's one from someone named Eric DeBotts. He says, if people have already a RedEdge on the Trinity, can they get an update kit or an upgrade kit to the dual cam? So this is related to the last question, but I guess I'd be interested to hear, Stefan, if I guess if someone did have, say, a RedEdge-M integrated with the Quantum-Systems Trinity, would they need to get the RedEdge-MX, or is there or would it fit in the payload bay?
Of course, they can upgrade. If they are existing RedEdge-MX and they want to upgrade to the dual camera system, that's possible.
Okay. Do you know if they're using the RedEdge-M? Or I guess you don't have. I think it would have to be MX.
Must be MX, yeah.
Okay.
There's a question if you're likely to demo this platform in the United Kingdom anytime soon. Of course, I can provide you our local reseller in the United Kingdom, and she can show it to you. That's absolutely no problem. I will answer that in the next few days. So there are a lot of questions, so we have a lot of work to do in the next few hours.